is my microphone on? Is it good? Okay, cool. Hi, so this title will make sense soon. My name is Mariko, that's my Twitter handle. As Potts mentioned, I'm based in New York City, and not only I work at Google office in New York City, I also organize a JavaScript community in Brooklyn called Brooklyn.js. So if you're ever in Brooklyn, it's a monthly meetup. You should definitely come. But as Potts also mentioned, I am a Google Web Developer Relations. I work as a developer advocate. So if I said that as a Google's web developer team, you might be thinking, yes, PWA. And so yes, I am going to talk about PWA, Progressive Web App. And I want to share what our idea of PWA is. Because we introduced this idea of PWA, and it's interesting. If I go to like a Google I/O or like a general web conference, programmers conference, and not the web, they kind of get confused what PWA is. And I get these questions like, so what's the difference between PWA and building an Android app? And to me, it's really clear that PWA is a website or web application that is enhanced with many capabilities. But we found a need to define what PWA is. And what we come up with was that PWA is a web application that is fast, integrated, reliable, and engaging. And I promise that this is the last slide I will say PWA, because I really want to talk about what it's like and what you need and what is available to make those fast, integrated, reliable, and engaging experience. And if you notice that, yes, it is intentional that we used it, fast, integrated, reliable, and engaging, to say FIRE. So it's kind of an acronym or like a tagline that we're using is a PWA is on fire. But before getting into the progressive web app story, I want to share my experience of using internet. So I started using internet when I was in 5th grade. Computers still look like this, with monitor that big. And I grew up in Japan. So in Japan, back then in 98, 99, there was a thing called a packet, like an unlimited packet. So if you connect to internet after 11 p.m., then the data was unlimited. That's why the internet was really slow, because everybody's trying to connect it. But my dad made an awesome decision that letting your 5th grade daughter stay up until 11 p.m. and then connecting to internet was a good decision. And he showed me how to connect to the internet. And because it didn't cost him anything, I was like, make sure I connect to the internet after 11 p.m. and then you can do whatever you want. Back then, the browser that I used was Netscape. And so to me, so if you don't know Netscape, when you access web page in Netscape and when the site is loading, which back then took a lot of time to load, it would animate. So in the dark, 11 p.m. after hour, I'm not supposed to be awake, in front of a computer looking at the thing, to me was very magical. That it felt like this internet is like a portal to somewhere else, and it was just a magical experience. Fast forward many years, our experience is on these phones, and we use this phone in very, very busy environment, and the phone using internet on the phone is integrated into our life. It's just very important part of what we do. So, the experience that I had of very quiet, sitting down in front of dedicated time without any distraction changed. And we need to rethink about what is good experience for the mobile use of the internet. And that's where FIRE comes in. And the fast, integrated, reliable, and engaging FIRE, what FIRE mean is that the fire that you kind of want to gather around and toast the marshmallows, not the fire, the garbage fire that you want to extinguish. So I want to share, and this talk is kind of like a general overview of what kind of things that you can do to make this experience. So let's talk about how to build a fire. Let's start with fast. Fast. When people say fast, the internet is fast, the website is fast, the speed of the internet is a part of it, but I'm not going to talk about that. But what kind of connection user has is a important piece of the puzzle. So the speed of the internet is how wide the band is and how clouded what's flowing inside of it is. However, as a web developer, what we can control is what's on top of it. So for example, on the server latency, like you can put cache or put your resources on CDN and make the response faster. Or you can optimize how you deliver data to the client. So I want to dig into this how and the transportation of the data part. So we used to have, we still have a thing called hypertext transfer protocol. If you're using 1.x version, then it goes like this. So you send a request from the client saying, hey, server, I want this data. And server receives the request and say, like, yep, I have that data, 200 OK, and then send the data back. And then your client says, OK, I got the index.html now, so I want the image for this thing, and those connections goes on. The modern browser allows modern browser allows it to have 6 connections at a time. And this is why domain sharding and icon splicing and all of the performance techniques comes in. You only can open a 6 connection to a server, and it's all staggered. Like what you want, once you send the request, you have to wait until the data to come back or the response to come back in order to ask for next data. So minimizing how many requests you send is one trick, and then also responding really fast is another trick. The newer version that you might be able to speed up this process is called HTTP2. So HTTP2 uses fundamentally different ways of transferring the data. So it only opens one connection between client and server. And inside of that connection, it is multiplexed. So the client sends the request in chunks, and then also server sends the data in chunks. And it goes like, hey, so there's the things I need. And it just client sends the request at a time, or one request at a time, but in the one stream. And you can hint to things like, this is a priority resource. For example, if you definitely know that you want index.html and the other one, you can kind of hint that too. And then on the server side, it will return the data based on those priorities and request queue. But client doesn't have to wait until one file to finish. You will receive different files simultaneously. Another thing is that the server can push the data. So a good use case of server push is index.html. So as a index.html font. So as a web developer who controls server, we know that when we define index.html and when we define like an icon face or font face, you definitely know that in order for that site to work, you need to deliver the icon font. At the time, if you're using HTTP1 of like kind of like a request and response, passing the data around, client receives the index.html and then reads the index.html and then say, I need those icon font, so they request another request. However, server or the person who provided the index.html already knows that the application definitely needs those font. So you can kind of set it like, well, when you send the index.html, then you also push the icon font without the client asking, because you definitely know that it's needed. Another thing that you can do to speed up this process of getting data is using something like cache. And I will dive into a little more about the service worker later, but you can kind of cache it on the client side and then access it faster. So that was how to get the data from server to client. And when we talk about front-end performance, what happens inside of the browser gets talked a lot, and that deserves a whole another talk that I don't have. So I want to share one exciting API, I think exciting API that will be very handy for you to control running your application really fast. Then that's intersection of server. How many of you heard of intersection of server? Yay, half of them. So that's awesome. So intersection observer is a new API that let you observe if an element is in the view or not. And by default, it's just a window. So it's basically tell you, is this element inside of user's view? But you can also set a parent element so that you can, things like, in this case, I have a div as a black box, and then another div inside of it as a child of the black box div that is colored. And just like setting up very simple code like this, 3 lines, well, in technicality more, but to kind of get the information if that is in the view or not. So you can use these things a lot because you're building image-heavy application. You can hint to download image once that element comes to the view. And you don't have to download the 10 images at the first or something, because you might not, like, you're not controlling users how far they're going to scroll, if they're going to get to that image or not. So this will speed up the process a lot. And at the Chrome Dev Summit, I made a silly little app. I really love this API because like it's not just for performance. I made this like a game prototype of using intersection observer. So this one, in this case, the parent is in the meteor, and then the rocket is the child, and kind of like orbiting inside, and telling that the rocket is not visible or visible. And you know, this is just a prototype. I'm thinking like kind of like a fake collision detection, and then building up the game. So I'm really excited about those things. So moving on to the next one, the integrated. Is first start with what's on the home screen. So integrated means that your web application that lives inside of your web browser feels like native app, you know, very much integrated to the user experience that you regular mobile user has. So in order to have your web application on your home screen, which is the first bit of integrated, right? Because you don't really necessarily open every app from the app, whatever the directory thing that you have on the setting. You would go through the home screen, right? So you want to be there as to be integrated. This has been long possible using just add to home screen, but this UI is kind of like embedded inside. You have to open the menu box, and then you have to go through those menu and then like add it to home screen or bookmark it really. And you have no control of where user is going to bookmark. So if I were to bookmark Flickr, as a Flickr developer, you might want the user to bookmark like a main portal page that everybody goes to after logging in. But as a user who is bookmarking it, I might accidentally bookmark, you know, my one picture page that's, you know, not the portal. And every time I click on the icon on the home screen, I wouldn't go back to the portal, but I go back to the one picture page, and you have to do another click. So it's like, as an application developer, you do not have a control of what kind of things that will launch from the screen. And that's not good. That's not integrated feeling. So Web App Manifest is here to solve that issue. So Web App Manifest is a single piece of JSON file that you can include in HTML in order to hint the browser what to do with those situations. So you can specify things like a short name, which will be used under the icon when you save it to home screen, and of course the size of the icon and what kind of icon to use. If your application have manifest JSON, then when you load up from the home screen, the browser will create a splash page based on the icon and name and background color you specify. The issue of you don't know what kind of page would open up when user tap on the screen or tap on the icon will be solved with start URL. So as an application developer, you can specify, okay, on start of this web app, please go to, you know, I don't know, /portal or /profile or index.html, and you absolutely have a control over that. You can also have a control of how to display your application. So is it going to open as a standalone app without the URL bar, or orientation? So if you're making like a piano application or something, you might want to open the application on the portrait mode, not the vertical side, because you need those interactions or something. So you can specify those. And in Android's case, the theme color that you use are used when the apps are on the drawer mode. So you can kind of specify many things that feels like native app. And this manifest.json is supported cross-browser. However, WebKit is not, so you still have to do the a traditional way of specifying install icon stuff. Once you have that manifest.json, then this can be used to prompt install. So now with this feature, user doesn't have to click on the menu icon and then go to bookmark and then save it to the home screen, but browser will ask user, hey, you use this application a lot. Do you want to save it to home screen? And browser will use these 3 signals to decide whether to prompt that or not. So first is a web app manifest. Kind of makes sense. You need those data to save it to the home screen of what kind of icon to choose and what kind of text to display. It needs to have offline support with service worker, which I will get to later. But this is just so that when user opens your application without internet connection, to guarantee that user will get something and not the offline dinosaur and feels like error, right? So, and then engaged user. This is the metrics that browser vendors keep experimenting. But it's basically like determining. It's basically so that it doesn't trigger the first load when user doesn't know if it's good app or not. Another one, I want to share a few other APIs, not just the add to home screen that feels like integrated and feels like native app. First one is payment request API. So with payment request API, if you worked on e-commerce, you might have done like many form validation and how to like keep the user engaged to finish the checkout line. With payment request API, the application developer will only need to specify what kind of information you need. And the model provided by browser will pop up. And whatever the payment method that user is installed on the phone will be as an option. So it kind of drastically minimizes the friction of filling out the form and checking out. So that's kind of amazing. And I want to make sure payment request API is not like a payment collection API. It's just for you to get the data you need to send it to payment collection services. So like if you use Stripe, then you request the data that you need to process your Stripe payment, and then you have to process that payment. This is not a Google Pay API or anything. This is an open standard that you can use with any other payment collection services. The next one, I'm really excited, is WebShare. So WebShare let you share the data from web application to native app. You write very simple code of like navigator.share and what kind of information you want to share. And it will be saved to there. Let's see. Yep. It will open up the share drawer, and then you can see that now the link is saved to Google Keep. So you can kind of send the data to native app. Another one is media session API, which if you do a media apps, that's kind of exciting. So, and it used to be when you have a media app, this is the only thing that you get. And this is like, okay, but as like just adding those things, like a metadata, will make the experience a lot more rich and a lot more native feeling with like thumbnails and informations. And there's many things that you can do with Media Session API that we documented on our developer portal. So the third one is reliable. And reliable means network reliability, like opens up something whether or not the app is online, offline. So even in the case of Wi-Fi, which I'm at the moment on the Wi-Fi because my phone is from the US, and even though it says LTE, it feels very slow. it needs to, the web application should load, right? Like I don't, I have a feeling that the native app will always open if I'm online or offline. But I also have this like bad feeling that the web application will not open because it needs the connection, and the reliable experience will mitigate that part. This section is entirely dedicated to service workers. Thanks to Jake Horchwell for this slide. How many of you know service workers? How many of you have coded service workers? How many of you know what it does? So like I don't need to really do this job. So I want to instead, so there's a whole bunch of talks that our team put together about service worker. And you can lead those things if you really need a code sample. But I wasn't really sure how much knowledge that you have and how much I should share, if it's repeated or not. So I decided to share my take on what service worker is, which started 8 months ago when I realized that I have no idea what service worker is. So I wrote a picture book, and I would like to share with you. So in the galaxy very near to your palm of your hand, inside of this phone, there is a Planet browser. Inside of the browser, you might be familiar with what kind of element is in that browser or when the garbage collection happens. This browser connects to a server galaxy to get data using things called hypertext transfer protocol. If I say it and visualize it like this, it's so cool and it feels very futuristic. But in fact, it is just a series of pipes relaying the data. So the size of the pipe and the flow, how clogged the pipe is, determines how fast the browser can get data. And depending on where in the orbit this planet is, the pipe size may change, the length may change, it might be broken. And in the case that the pipe is not available, the Planet browser turns itself to the age of the dinosaur, kind of reminiscent of no technology era, and just like turns into total non-working things. Service worker is a thing to help this situation in order to make the browser feel like an app. So service worker sits in between the hypertext protocol, the network, and the browser. And the browser requests the resources or requests the HTTP request through service worker, and service worker can control how to handle those requests. So in this case, browser is asking, hey, I want the cat GIF, and the service worker checks the network, and above my head, there's no internet right now, so I'm going to return that from the cache that I served before. Another thing service worker can do is handle the background fetch. So things like a Planet browser can request like, hey, I have this cat photo. Oh, it's offline. Can you just like handle that? I'm going to go sleep, closed on the phone. But then once the internet comes back above your head, can you just handle uploading that? Service worker can do that. Another thing service worker can do is a push notification. So even if the browser is closed on your phone, service worker can wake up to send a notification, and then wake up the browser. So that's a little bit of a picture book. This was written when I was leading Jake Archibald's documentation about service worker, and the first line it said was, service worker is a programmable proxy or network proxy or something. And I was like, I have no idea what that sentence is. And I drew it. So now that you kind of know what service worker does, here's a few strategies to handle the service worker network request. The first one is cache, then falling back to network. So this is kind of simple. That you, Yep. So you request a resource in network, and once it fails, then it goes back to cache. However, this method has a little flaws. Like if the network request, when it goes, is like really slow and slow to respond, then user have to wait, because in order to go fall back to cache, the network has to respond something, and that might be really slow. Another one is a cache then network strategy. It basically takes the old stale data first while you are trying to attempt the new data from network. And once the new data comes back from network, then you swap it. This is really good, but you have to kind of make sure that your UI is not bothersome. You wouldn't want the user to show a page with red, beautiful design, and then just because you did the renewal oversight, you don't want to have interrupt the users that is already interacting with your old interface with like completely different UI once you update it. So you have to be a little careful. You can do things like update the leaderboard of the game or like insert new article on your media page, but you have to be a little careful about how to update those information. The generic fallback is kind of like, go to cache and then go to network, and then if both of them fails, then kind of show the default, sorry, you were offline page. So in the case of Guardian, the news site, the data being fresh is really important, but also they want to keep the users while they're offline. So they show a crossword puzzle as a generic fallback when network and the cache fails. And once the internet comes back, then they would ask you like, hey, you seem to be back online. Do you want to keep playing the game, or do you want to load the content? So while user is offline, they didn't lose the user's attention. You kept the user's attention by playing the game, and once the network comes back, you can load it up. So this seems very complicated. Our team worked on the library to help you do this because something like icon, you want to use one caching strategy. Something like content, you want to use the other caching strategy. And writing service worker code gets really complicated. So we have a kind of library to help you do that called workbox.js, and which will declaratively define what kind of caching strategy you want to use. So I want to go into last one, which is engaging. And in this case, I want to talk about push notification. Yes, the push notification that you might know as this. So with Service Worker and with new API, the web browser can use a push notification on the phone, but it is known to be kind of annoying. And it's also bad news. If you do those annoying interaction and user blocks, you will never be able to ask to send a push notification again because user once set it block. And browser says, oh, this user says block. So the community developed a pattern to avoid this called double permission pattern. So basically, what it is first, it is a model that doesn't actually prompt the push notification. It asks you like, hey, do you want to get push notification? And then when user says yes, then trigger the real push notification that came up on the browser's one. So that to ensure that user will not block. Because once user click on block, you cannot come back later. I want to share how Weather Channel does this, not the double permission pattern, but I think Weather Channel has like a really good way of asking for push notification. First, they put the permission to the contextual and user-initiated page. So you have to go into settings page, and user is in the mindset of, I want to set and think about push notification. And then user goes, select those. And then triggers the push notification, which in this case, because the user initiated it, there's like no surprise that they will allow it, right? They will not likely to block it. And then once that's done, then it gives the user options to disable it as well. And this one gets really important because add to home screen or install, that I will talk later, is kind of like a bookmark. So when you delete the add to home screen icon on the phone, that will not delete the cache, that will not delete the push notification settings. So you really need to provide users in order to control those things too. A lot of the UX studies are done and shared on our team site. So lastly, I'm over time, but quickly I want to go through the secure experience. The things that I've been talking about, the powerful APIs, it all requires HTTPS. If you know what HTTP and HTTPS, it makes sense. But I want to briefly explain why these needs HTTPS. So HTTPS is like sending secret letter. If you're doing non-secure, the regular HTTP, it's like sending the data in flat. And in the real-life experience, I always explain it as like sending a postcard. Your mailman can read your postcard and whatever the personal message that you are sending on the thing. Or the malicious attacker can intersect with your mail and then like maybe try to change the message. And this is like kind of real-world explanation of HTTP. Like you don't know if it's changed by somebody else malicious or not. And somebody might be eavesdropping. HTTPS makes it encrypted, which means you and the person you trusted to send the data can only read it. And I explain it as like a magic sunglass that you need to wear to read those messages. And then the message is also have an integrity of this is guaranteed coming from that person. So in order to make these sunglasses, whole bunch of things happens. First, encryption. Basics, I'm super over time, so I'm going to browse through. But we use things called public key encryption, where you can only encrypt with public key, which you share with your counterpartner, and then you can only decrypt with private key, which you keep it secretly. So creating this network handshake goes like this. So you say, client says, hey, I speak this kind of public key encryption. Let's start HTTPS connections. And then the counterpart says, OK, let's use this thing, this version of public key encryption. And here's my certificate. And here's my public key. Then you use that public key that they provided to encrypt the master secret and send it back to the counterpartner. In this way, you and counterpartner have a secret together, the shared secret that you only can read because you did it with public key encryption. And once that's done, you can use those seed to create the special sunglass, which then use it to read those messages. If you're curious about how and why and how to do fast HTTP and how HTTPS and how to care about SEO and things, there is a video from I/O 2 years ago about misbusting HTTPS, and I highly recommend it. So in conclusion, build the application with FHIR in mind, but in order to do the FHIR, you need to be secure because HTTPS service worker, for example, you don't want malicious JavaScript living in your users' cache that might be tinted with malicious attackers and verified as coming from you. That's really bad for your brand. And you can kind of understand why HTTPS is a requirement for those powerful APIs. Hopefully this was interesting, and hopefully this gave you an overview of what we think as a very engaging and nice user experience for the age of mobile internet. Thank you very much.